Good morning, and thank you for joining the How to Leverage Machine Learning webinar here organized by Beyondsoft. We have today with us myself, Benjamin Soon, as well as Dr. Robert Newman, who will be presenting the majority of the webinar. Rob here has a doctorate of mathematical and chemical geology, as well as 17 years of experience in high-density and real-time telemetry data, signal processing, big data analysis, Python development, as well as technical leadership. Also in the room with us are Benjamin Warden. He is the lead technology architect who has over 13 years of experience designing business intelligence solutions, architecting relational and multidimensional data structures, and transforming data into actionable information, as well as Dr. Jimmy O'Donnell, who is our lead data scientist. Jimmy here has a PhD in ecology and evolutionary biology from the University of California, Santa Cruz. He is also an expert here in machine learning and predictive modeling. So without further ado, I'm going to pass it to Rob. Rob?
Great. Thanks so much, Ben. It's a pleasure to be here and have you all join us today. And as the title says, we're going to talk about how to leverage machine learning. A brief note about the tone of this presentation. There is going to be some technical content, but the goal here is to really articulate the value of machine learning and predictive analytics to decision makers and also help you get started on your machine learning and predictive analytics journey. To that end, we're going to be talking about what machine learning is and what predictive analytics is, and why should we even use it. Then we're going to touch on data analytics and the state of the industry, where people are going from traditional sort of business intelligence, moving through analytics maturity up to predictive and prescriptive analytics, which leverage machine learning and artificial intelligence. And then we're going to talk about some of the definitions around machine learning. Like what is machine learning? Some of the myths versus the reality, and also some foundational concepts of machine learning. And that's going to be pretty much as deep as we get technical-wise. Following that, we're going to talk about real-world applications of machine learning and predictive analytics. We're going to talk about some of the large companies, many of them based up here in Seattle, where we are, and how they're leveraging machine learning to gain greater business value and business insight and beat their competitors. We're also going to walk through 2 or 3 case studies that our team has actually built successfully for our clients, and talk through what we built, how it was successful. Then we're going to touch on what some machine learning best practices are, and also some common obstacles that we've encountered with our clients when we build machine learning solutions for them. And then finally, we're going to touch on how do I actually start using machine learning and predictive analytics in my business. So what is machine learning and predictive analytics? So predictive analytics uses machine learning to exploit transactional and historical data to forecast the probabilities of specific future events. What this does is it actually allows you to make data-driven decisions about future results or events with confidence. There are multiple applications for this, right? So if you go to a website that has a recommendation engine, this is built on top of machine learning. Looking at pattern matching, if you want to do rapid targeting for sales and marketing efforts, if you want to do analysis of sentiment and maybe change that and improve that, that's capable with machine learning. And also creating automated workflows, for example, service desk automated ticket resolution. That's a perfect example of using machine learning to actually answer tickets in an automated way to free up your service desk agents to allow them to focus on ticket escalations or higher priority tickets. So why should we use machine learning and predictive analytics? We live in a data-centric world. Everyone knows this. We're collecting more and more data through more and more channels, whether it's sales data, financial data, telemetry data, sentiment analysis from social media. This is the reality of our world. Companies that can generate high quality data and can rapidly process it have a clear competitive advantage. predictive analytics using machine learning can leverage that data for an even better and bigger competitive advantage. And if done correctly, predictive analytics can generate higher quality predictions than humans, so more accurate, less biased. You can generate results much faster and iterate on them and improve accuracy over time. You can predict problems before they happen, so improving efficiencies and lowering the number of defects. This is particularly important in the manufacturing industry. And it's relatively simple to modify and repeat the processes, so it's more flexible and agile. So next step is to talk about the numbers. Why use machine learning? Spending across all verticals, this is a report by the International Data Corporation. They forecast that spending on artificial intelligence and machine learning will grow from 12 billion in 2017 to 57.6 billion by 2021. That's almost a 5 times growth across all verticals that companies are spending on artificial intelligence and machine learning. So if your company isn't doing it, a lot of other companies are doing it, and they're getting that competitive advantage. The second point is that business intelligence platforms that utilize machine learning are growing faster. 13% compound annual growth rate through 2021 for business intelligence platforms that utilize machine learning, while traditional BI platform growth is only predicted to be 8% compound annual growth rate. So if you can leverage machine learning within your BI platform, that's the way the market is going and what you should be doing. And finally, in 2018, machine learning and AI is the top data initiative. 61% of organizations most frequently picked this as their company's biggest data initiative. So moving on to the data analytics state of the industry. What we have here is an infographic that shows on the left-hand side the analytics maturity. And this is modified from the Gartner Analytics Maturity Curve that has been around for 10 plus years. And what it shows is that most companies are using descriptive or diagnostic analytics currently. Descriptive analytics is looking at what happened. So typically this is looking at Excel spreadsheets, using that to analyze the state of your business. The second level is looking at diagnostic values, like why did something happen? And this is typically using self-service BI platforms such as Microsoft's Power BI or Tableau. And this is trying to understand why something happened. Gartner has identified a competitive divide between diagnostic and the next 2 levels of analytics maturity, which is predictive, so what will happen, and then prescriptive, what's the best that can possibly happen. As you move up this analytics maturity curve, your market share potential increases. You get better insights, you can make better decisions, you get greater market share. The number of small to medium-sized businesses and small to medium-sized enterprises that are using descriptive and diagnostic analytics is about 80%. But if you go across that competitive divide to predictive or prescriptive, only less than 25% of small to medium-sized businesses are using predictive analytics, and less than 5% are using prescriptive analytics. The differences between predictive and prescriptive is that predictive analytics typically uses machine learning to give you an idea of what the probability of something occurring will be, and you actually have to make the decision. This is like advanced statistics, machine learning. Prescriptive analytics is actually full-blown artificial intelligence. So self-driving cars is a perfect example of prescriptive. That's when you trust the computer to actually make the decision for you. It understands what's the best thing that can happen, and it makes that decision. So machine learning and predictive analytics are most successful when they're coupled with high-quality big data and a rigorous data science practice. And that's what we're going to be talking more about. So let's talk about some definitions and history of machine learning. This is a infographic that is borrowed from NVIDIA, and it talks about the relationship between artificial intelligence, machine learning, and deep learning. Often these names are conflated or confused, so I wanted to give some clarity around what each of those things are. The simplest way to think of their relationship to each other is to picture them as concentric circles. AI, or artificial intelligence, is the idea that came first. It's the largest and has been around since the mid-1950s. Back then, the dream of the artificial intelligence pioneers was to construct complex machines that possess the same characteristics as human intelligence. This is the concept of general AI. So think of, for popular culture, think of C-3PO from Star Wars or the Terminator. This is still beyond our grasp, although we're getting closer with the rise of self-driving cars. What was actually accomplished during that period was narrow AI, and that is technologies that can only perform specific tasks as well as or better than humans. The early pioneers founded this by teaching computers to play games. And one of the earliest examples is computer checkers developed by Arthur Samuel while at IBM in 1959, who coincidentally coined the term machine learning. Moving on, machine learning, which blossomed later and is the focus of our presentation today, started to flourish in the 1980s. At its most basic, machine learning uses algorithms to study data from a specific source or sources. It learns the relationships between the data, and then it makes future predictions given some new data from the same source. Businesses today collect a lot of data from lots of different sources. For example, sales and marketing metrics, financial data, customer relationship software, social media engagement, and they commonly have key performance indicators that they use to determine how effective their business is running. Using all this data to train machine learning models to provide predictive insights can improve business KPIs and make them more efficient, more competitive, and more profitable. Machine learning is the most common application of artificial intelligence to everyday businesses today. Deep learning, which is driving today's artificial intelligence explosion, fits inside both AI and ML. It's gained prominence due to the drastically reduced costs and increased power of computing, especially from cloud computing platforms like Amazon Web Services, Microsoft's Azure, and Google's Cloud Platform, which have commoditized computing, and also the exponentially increased volumes of data available for training models. Image recognition is the classic example of deep learning, with applications such as identifying cancerous cells. A recent NVIDIA study showed that deep learning drops the human error rate for breast cancer diagnosis by 85%. Also, object classification in photographs, and self-driving cars, which I already mentioned, by the Google subsidiary Waymo and Uber. Other applications of deep learning include voice search and voice-activated intelligent assistants, automatic translation of text and images, and recommendation engines on video platforms. So that's kind of an overview of the three main arms of artificial intelligence. And as I said, we're going to be focusing on machine learning for this, the rest of this presentation. So let's talk about some myths versus reality. Some of the myths around machine learning is that it's all about the right algorithm. If I get the right algorithm, it's going to solve all my problems. The second one is machine learning always performs tasks in real time. The third myth is that machine learning technologies are a black box. We don't know, they're magic. We don't know what goes into them. The fourth one is that machine learning is absent of human bias. The fifth one is only skilled data scientists can use machine learning. The sixth one is a single machine learning model will solve all your problems. And the last one is you have to use deep learning. And as we can see, these are myths. The reality is, in terms of the algorithm, it's not really about the algorithm. Many algorithms can be similar in performance. What's really important is the quantity and the quality of the data that you're using to train the model. The second one around machine learning in real time, it is possible, but only systems built for online learning can perform in real time. The third one is machine learning technologies are a black box. They can be, but they don't have to be. One of the things that the Beyondsoft predictive analytics team use are open source software packages such as Python and R, which are standards across the data science industry. And that allows us to build on top of a whole established framework of global data scientists. And It is transparent and clear about how we're going from step A to step B to step C. The fourth one is machine learning is absent of human bias. Data has human bias, and data is used to train machine learning models. So unless you're careful, machine learning models also inherit that bias. And there's a whole suite of presentations out there that talk about bias in machine learning and some of the pitfalls and dangers to be aware of there. The fifth myth is that only skilled data scientists can use machine learning. That's true if you start getting deep into the weeds around machine learning, but today major tech companies do have plug-and-play machine learning platforms, such as Amazon, Google, and Microsoft. Second to last, a single machine learning model will solve all your problems. This is it can be true for relatively simple applications, but typically ensembles, which are multiple stacked machine learning models, often work the best. And the last one is you have to use deep learning, ! This is not true. You should use the most applicable model for your problem. So let's go over some machine learning training and evaluation concepts. The first one is the model or the algorithm. So a machine learning model is an abstraction of the question you're trying to answer or the outcome you want to predict. Models are trained and evaluated from existing data. The second concept is a training data set. So when you train your machine learning model from data, you use a known percentage of your data set. This varies based on the problem that you're trying to solve and the machine learning model you're trying to use and the amount of data that you have at your disposal. But typically this is around 70 to 80% of the total. And you make adjustments to your machine learning model based on the data characteristics to get the most accurate answer. The third concept is the idea of a test or validation data set. And this is where you validate your trained machine learning model with another part of the known data set. This is a smaller subset. It varies between 15 and 25% is common. And you do this while tuning your hyperparameters to ensure that the trained machine learning model is performant. And then finally, when you've got this trained machine learning model, you want to use a smaller subset of data called the holdout data set. And this is optional. Once you have a satisfactory trained final machine learning model, you evaluate it using the remaining percent of the data. You use data that you already know the outcomes for so you can determine whether your model predicts accurately or not. So what's a typical workflow? I'm going to walk through this. This is actually taken from Ben Hamner's presentation in 2014 at the Strata conference. He is the lead scientist of the Kaggle platform. And so thank you to Ben for letting me borrow this. But this talks about the workflow. And here we start with a business problem. What are we trying to solve? Are we trying to predict sales? Are we trying to build a spam filter? Are we trying to auto-grade term papers? Are we trying to identify dogs versus cats? Whatever your business problem is, that's the place to start. Then we source the data from your systems, whether it's a CRM system, an ERP system, your financial data, your sales and marketing data. You've got to get the data. Then you split your data set into a training set, a validation set, and test data set. Then we select an evaluation metric, which determines how to measure the performance of your model for your particular business problem. This could be classification accuracy, log loss, sensitivity, specificity, precision, recall, an F1 score, which combines precision and recall, area under the ROC curve. There's lots of different ways of measuring the performance of your model related to your particular business problem. But what it does is it requires domain knowledge of the problem and a statistical understanding of what you're attempting to predict. Then we perform feature extraction. From the initial set of measured data, we build derived values, which are also called features, that are information and they're non-redundant for the machine learning model. And what I mean by non-redundant is, let's say one of your data values is measurement. You don't necessarily need measurement in feet and in meters. You can use one or the other. So those values are redundant. So you want to simplify the data as much as possible that you're putting into the model. Then we train the model. Then we move on to feature selection. This is where we determine a subset of the initial features which provide a reduced representation of the complete initial data set. Then we move on to model selection. We select the best model for the business problem we're trying to solve, and then we move everything into a production setting. Note that this process, I've shown this process being linear, like one step after the other. It's actually iterative rather than linear. Sometimes we can go through and you have to go back a step. Maybe your data's not good, maybe you need to cleanse your data, maybe you need to transform your data more, but it's a very iterative process. It's not once and done. And it's the science, in quotes, in data science. So, which algorithm should I use? This is a great question. There's no best method or one size fits all. It depends on the size and the type of the data that you're working with. It depends on the insights that you want to get from the data. And it depends on how those insights will be used. Two general guidelines or groups, though, in terms of choosing machine learning algorithm types, it's supervised learning and unsupervised learning. You use supervised learning if you need to make a prediction, for example, the future value of a continuous variable such as temperature or a stock price, or if you need to do classification, such as identify the makes of cars from webcam video footage. The other group of machine learning models are unsupervised learning. So if you need to explore your data and you want to train a model to find a good internal representation, such as splitting up your data into clusters. So in terms of real-world applications, let's have a look at how some well-known companies are using predictive analytics and machine learning to drive revenue. This will be no surprise to many of you that Amazon uses machine learning in multiple applications. In recommendation engines, it looks at customer purchases, customer views, items frequently purchased. So Amazon serves up the right product for individual customers when they're shopping online. Product selection and catalog services. They use machine learning to evaluate millions of products every day and identify and prioritize new additions to Amazon's selections. Advertising technology. Amazon analyzes billions of ad impressions and millions of clicks to solve problems related to robot detection, publisher quality, contextual extraction, relevance modeling, performance prediction, and impression, click, and pricing. Amazon Echo and Alexa engine use machine learning for voice recognition, dialogue management, and natural language processing. And other examples include inventory and demand forecasting and product pricing. Sometimes this is based around seasonality. For example, you probably want to change the price of your air conditioners in November and December and January. Moving on to Airbnb, which is a startup most people are familiar with, located down in San Francisco. Airbnb uses predictive analytics and machine learning for dynamic pricing based on booking probability and predicted demand. Airbnb allows you to change the price of your property based on different probabilities, and these are generated from hyperlocal neighborhood creation, doing image analysis and ranking of professional and organic property photos, and looking at local events that may cause demand peaks and troughs. An example would be if you have a rental property in Austin, Texas, and South by Southwest is just around the corner, you can charge much more for your property, and you have a high probability of renting that property based on that event happening. Netflix uses machine learning in multiple applications, including serving up viewing personalized recommendations, content promotion and content price modeling, programmatic marketing, efficient content delivery, and the adaptive streaming quality of experience. Another Seattle company is Zillow and the Z-Estimate. Zillow uses machine learning to serve up personal viewing recommendations, content promotion and content price modeling. It does nearest neighbor analysis to determine the value of your property, and it looks at public and owner-submitted data to come up with the estimate of your property value. YouTube uses machine learning to do automatic video classification. Is the video that you uploaded about cats? Is it about dogs? What's the business domain that it's about? Is it about machine learning? Is it about programming? Is it about cooking? And it does this using machine learning around video analysis. It also uses machine learning to build its recommendation engine. And finally, Facebook uses machine learning to do facial recognition, determine its search rankings, determines whether news is fake news or real news, automated video captions, and translation as well. So in general terms, here are some ways that industry leaders are using predictive analytics to drive business impact across multiple verticals. I'm not going into details on this slide, but what I want to point out is that companies who take advantage of predictive analytics are able to meet unique objectives that drive better business impact. In the manufacturing vertical, looking at preventative maintenance or demand prediction and defect detection are huge competitive differentiators. In the finance industry, fraud detection, detecting when a credit card is used fraudulently, machine learning is used for that. Refining the customer user experience in ATMs and also in the bank layout when you walk in is based on machine learning. And then loan risk assessment, which is a classic one. In the retail vertical, doing rapid targeting, building recommendation engines, and doing dynamic pricing, which I talked briefly about before with Amazon. In the healthcare industry, looking at preventative care, doing diagnosis in medical imagery, for example, detecting cancerous cells in MRI scans. And then also drug discovery and also drug relationships to each other. Healthcare companies look at how certain cocktails of drugs might affect you based on your DNA. The oil and gas industry uses machine learning to do reservoir analysis and modeling, alarm management and investigation when leakages may occur, and also well test analysis and prediction. And finally, the last vertical is agricultural. Here you can use machine learning to predict beneficial plant genes that would maximize yield. They also use IoT and machine learning to look at livestock efficiency and optimization. An example that I read about in preparation for this talk was looking at cow facial recognition for monitoring the behavior, the body condition score, and how it feeds during its lifetime, and also crop health monitoring. And now we're going to move on to some examples or case studies that Beyondsoft has done. We've worked with a predictive analytics, our predictive analytics team has worked with a leading automotive manufacturer to develop a machine learning web service that predicts when a visitor to their website is most likely to become a hard lead. And when they are likely to become a hard lead, we can provide custom page content for them. A second case study is that Beyondsoft has a large onshore service desk support, and our predictive analytics team worked with our clients to develop a machine learning automated ticket resolution workflow using dynamic text analysis from emails or the ticket content, and we managed to increase ticket resolution by 10%, or automated ticket resolution. And finally, our predictive analytics team partnered with a home decor startup to build, optimize, and productionalize their machine learning-powered product catalog discovery technology, which allowed this startup to do an automated onboarding and labeling of new product catalogs with confidence. So, moving on to best practices. One of the first best practices when using machine learning is it's critical to define your business goals. And one of the things that we have encountered is that our clients who have already established key performance indicators is a huge boost to allowing us to bootstrap a machine learning system for them. If you know when your company is being successful or not, and how it's being successful over time, that's a huge differentiator. Also, what are you trying to predict, and why are you trying to predict it? Understanding that is key. Then also, what constitutes success? Do you need your machine learning model to predict with 50% precision? Do you need it to predict with 60, 70, 80? What constitutes success? And sometimes this depends on your business vertical. Maybe if you're in the insurance industry, you want to predict premium price updates based on a 50% probability. Or if you're in sales and marketing, maybe you just want to see a 10% uptick in sales based on your machine learning system. So understanding what constitutes success is critical. Second one, which is one of my favorite terms, is don't try to boil the ocean. Don't try to solve all your machine learning predictive analytics problems at once. The best thing to do is to identify 2 or 3 specific business problems, typically your low-hanging fruit, that can be addressed. Once you do this, and you can demonstrate success to the key stakeholders in your company, you can get buy-in, and then you can expand your machine learning practice. But what you want to do is you actually want to build the system first and demonstrate success, and then your company key stakeholders become evangelists, and you can start building a larger machine learning practice. And the last one is be patient, and remember that this process is iterative. Trying to build a machine learning practice and expecting results within 1 to 3 months is just not realistic. You've got to be patient, you've got to make sure you've got good data going in, you've got to make sure you have good statistical processes, and that you can productionalize it. So be patient, and remember that it doesn't change in a day. And the last one is that data integrity is key. You need to have a robust understanding of your data sources and their quality. Also, who owns the data? Have you got buy-in from that team who owns the data, whether it's your IT department, whether it's your marketing department, or your financial department? Also, start with a well-constrained business question that it has enough data to be statistically valid. And sometimes it's better to work with raw data rather than normalized data. Maybe you've got this beautiful data set or a data warehouse that you're building reports from, but it's so normalized, it's hard for a data scientist to work with. You may need to go lower down in the data flow chain and work with more raw data to generate insights. So, what are some of the common obstacles that we've encountered during our machine learning and predictive analytics practice? The first one is overfitting of your model. Typically, if you get 100% predictive power, you've probably overfit the model. And the overfitting is when you've trained your model really well on training data, but you haven't used enough of a holdout set or a validation set so it can't predict when it gets new data really well. The second common obstacle is your data sampling and splitting plan. You want to ensure that your train, test, and validation data sets are using independent samples. The third one is data leakage. This is where information outside of the training data set or using your target variable is used in training the model. And I'll give you some examples of this because this can be a little confusing. A model that uses data in the model that would not be accessible in a production system. So for example, image recognition of animals where your backgrounds of the animals are not taken into account. If you use your training set of your cat images, they're all inside with a couch in the background or carpet, and all your dogs have the photo taken outside on the lawn. If you give your machine learning model a picture of a dog indoors, it may predict it's a cat because of the image background. It's been trained on indoor photos of cats. Also, a model that uses the target variable itself as the input. So let's say we're trying to predict the meteorological conditions for rain. If we use the data point that it's raining to train the model, we could conclude that it always rains on rainy days, which doesn't give us any insight at all. This is often unintentional, and it's facilitated by the data collection, aggregation, and preparation process. It can also be subtle and indirect, making it hard to detect and eliminate, but data leakage is common, and it should be accounted for. Fourthly, data quality. Inconsistent, duplicate, and corrupt data needs to be identified and explicitly handled. Also, what do you do about missing values? If you have missing values in your data set, do you fill them with zeros? Do you fill them with averages? How do you handle that? So understanding what to do in that scenario is critical. And finally, you want to make sure that your data is stationary. And this is a data science and statistical term of stationary versus non-stationary. And what you want to ensure is that your data generation process doesn't change and introduce new variables. If you have trained a model to predict whether an image is a cat or a dog, if you give it an image of a raccoon, that's outside of your training data set. So what does it do there? Does it predict that it's a cat or a dog? It's going to predict either one of those two things. It's not going to predict that it's a raccoon because it's never had a training data point of a raccoon. And also, you want to make sure you introduce new variables during this process. And finally, machine learning isn't one and done. I touched on this earlier. Data science is not a linear process, it's iterative. You've got to be prepared to retrain your models, you've got to be prepared to work on them iteratively and improve over time. So, how do I get started on the machine learning and predictive analytics path? In our experience, the common barriers to predictive analytics and machine learning have been complexity. It's still a relatively complex domain. Also, the compute time and expense of training these models can be expensive. It's not particularly easy to use. Once you've got this trained machine learning model, what do you do with the output of the data from it? Also, it can be tough to sell internally to key stakeholders, and it can be resource expensive. Data scientists are a very hot job right now. They can be expensive to build a data science team. So here at Beyondsoft, we have a platform called BeyondLearning. And this is a machine learning as a service. And what this does is it helps you overcome these barriers. It provides affordable, white glove support to deliver actionable predictions that positions your business to streamline operations, increase revenues, and delight your customers with these business insights. So there's 4 pillars to our BeyondLearning machine learning as a service. White glove service is the first one. We cross the competitive divide. We help you cross that competitive divide between descriptive and predictive analytics with a trusted partner. The second one is transparency. We want you to have confidence in your predictive insights, and we do that through our use of industry standard packages and processes. I mentioned Python and R, and using these cloud compute platforms such as Amazon AWS and Microsoft Azure. We also have multi-vertical expertise. Beyondsoft has over 10,000 consultants worldwide, so we can tap deep industry expertise to meet your company's unique challenges. And finally, empowerment. We want to make sure you can take control of the predictive insights that you get to transform your business and achieve success. And we do this by building interactive dashboards. So we either use Microsoft Power BI or Tableau or Amazon's QuickSight to build these dashboards that show you the performance of your model and what your raw data looks like against your predicted data. And what do our engagement models look like for BeyondLearning? It's an efficient and a cost-effective approach. Typically what we do is we either do a consulting engagement, a discovery engagement, or a proof of concept engagement. These typically range from 4 to 8 weeks in length, and we come in and we look at your data and help you determine what data you should be using for your machine learning model. Then we train the machine learning model for you. We do deployment of that machine learning model in a test environment, and then we build an interactive dashboard to allow you to view the results of that. And those are typically 4 to 8 weeks. If you're satisfied at the end of that proof of concept or consulting engagement, we then move into a production workflow and deployment. And this typically takes between 8 and 24 weeks, depending on the size of the machine learning project, the complexity of the data, how much the data needs to be transformed to be useful for a machine learning model. And here, we build the system, we deploy it into the public or private cloud, we integrate it with your business processes, and we build interactive dashboards for your various business owners. And at a regular cadence, we retrain your machine learning model. And there's also support there for you if you have questions around your model or the dashboard. And that is the end of my presentation. So I will pass the mic back to Ben, and As Ben mentioned earlier, there's myself in the room. There is Ben Warden, who's our lead technology architect, who works a lot with data ingestion, processing, and normalization. And Dr. Jimmy O'Donnell is in the room as well, and he's our lead data scientist. And with that, Ben?
Thanks, Rob, for that extremely insightful talk. We are going to spend some time to answer some questions that are coming from the audience. So the first question that we have up here is stated like this: I own a mid-sized printing company. How do I get started on ML, and what is the typical time frame? Again, that question is, I own a mid-sized company. How do I get started on ML, and what is a typical time frame?
This is Ben Warden. I think Rob's slide kind of gave, at the end there, gave a little bit of insight towards this, but we like to start with a 4 to 8 week timeline to select the data, work with you, understanding the business to identify the problem we're going to try to solve, determine the metrics, and get a proof of concept that actually provides insight, right? So 4 to 8 weeks for your first predictive insights, and to understand the problem well enough to start building a productionalizable system. It's typically another than 3 months or so to actually get it up and working as a production system. So in total, you know, it could be anywhere from 3 months to 5 months is the general timeline to get your first productionalized machine learning system up and running.
I would also add that it also depends on the quality of your data, right? If you know what your data looks like, and also you know the business question you're trying to answer with machine learning. I see that you own a mid-sized printing company. Are you trying to improve your sales? Are you trying to reduce the amount of defects in your printing process? What's the business insight that you're trying to generate from machine learning? And understanding that and quantifying that, and then seeing if you have the data to support that business question is key for you. And we also offer consulting engagements where we come in and we help do an assessment of your data and also your business processes to help you understand whether machine learning is applicable for you.
So that being said, then there's another question here that states, how do I get started with machine learning if I don't know the quality of my data? Again, that question is, how do I get started with machine learning if I don't know the quality of my data?
That's a great question. I mean, the honest answer is there's no way to skip to the third level of that Gartner Analytics maturity curve without having done anything in the first two. If you don't have good insight into your data, if you don't have data-driven objectives within your business, that you're already making plans using historical data, it can sometimes be a little daunting to ramp up rapidly. There are often low-hanging fruit for machine learning still, just working off of very raw data, but you'll expect more data cleansing and to spend longer in that kind of discovery and proof of concept, because you have to turn the lights on in the room and assess the data before you can even get started. Whereas if you already have a mature data practice and you know that you're trying to improve your opportunity ROI and you have good sales data that is giving you accurate opportunity ROI, then you're probably going to be able to ramp up faster. And similarly with this, how much data is enough, that depends tremendously on what you're trying to solve. If it's a problem that has seasonality, for example, it may be more so than the number of rows, how many years, right? Because you have to have enough to capture the seasonality.
Also, it could be dependent on the grain of your data, right? If you want to look at day-by-day sales and you want to do forecasting day by day, you need to have sales data on a day-by-day grain rather than on a week grain or a month grain.
All right, thanks for those answers. The next question that we have up here is, once I have a good model, how do I get business value from it? Again, that question is, once I have a good model, how do I get business value from it?
That's a great question, and what I'm going to do is I'm going to talk a little bit about the case study that we did for the automotive manufacturer in a little bit more detail. So what we did there was we created a model that would look at all the visitors to a website and from the actions that the visitors to the website did, we determined which actions would actually result in a car being sold, right? And those actions might be looking at the list of all available cars, looking at specific types of car, whether you're looking at SUVs versus convertibles, then also looking at whether the person or the visitor to the website started doing a build your own. Like a lot of automotive websites actually provide this, you can build your own custom car, right? So build your own is an action that goes into the model. And then also, did they complete the build your own? Because sometimes visitors to the website start on a build your own and then they leave, they don't complete it. So did they actually complete the build your own process? And also, did they look at specials? Did they look at list of dealers? Did they look at locations near them? All these actions that are taken on the website were used to train our model. And once we identified that sort of needle in the haystack of all these visitors to a large automotive manufacturer's website, you know, there's a very tiny percentage that actually buy their car online. But identifying that is really critical. So once we managed to identify that with a certain level of accuracy, we built what is called a RESTful web service. And what that is the ability of a website to send a background query to a system and says, hey, this user has taken this action, this action, this action, and this action. Are they likely to buy a car? And then that web service responds with a, yes, there's a 50% probability that they're going to buy that car. Or they might do 4 out of the 5 actions or 3 out of the 5 actions. But every single time an action is taken, it sends a query in the background to this web service. And that responds with a scored probability of whether they're going to buy a car. Now, depending on what that scored probability value is, we built different custom content pathways for them. So let's say they had a 50% probability of buying a car. We returned that information to the website, and we had a pop-up appear on the website saying, hey, if you're interested in buying a car in the next 24 hours, here's a special deal for you. Maybe it's like a 50,000-mile warranty, or maybe it's an upgrade to a leather interior. That is up to the business owner to decide, but what we're trying to do there is, based on these scored probabilities, we're trying to drive your website visitors down that sales funnel. And looking at their actions and their behavior in real time allows you to kind of pull them in and convert them into making a sale more than would have been the case if that machine learning model wasn't there.
I think more generally, right, a big thing you have to do is consider not just what you want to predict, but where you're going to integrate the outcome of that prediction in your existing business processes to drive action. Because if you just have a chart that tells you, a forecast, that can be sort of useful for insight and planning. It can help guide your thinking, but it's not as direct in its impact as if you have a defined action that you're going to take based on the predictive outcome and systems that you're going to integrate that into.
All right, thanks. The next question we have on here is, sounds like ML is meant for enterprise companies and not smaller companies. Is that correct?
I would say that is, it's not quite correct, no. Machine learning has typically been the domain of larger enterprise companies, and that is because larger enterprise companies have the resources available to them to build a data science team and to spend a fair amount of money on compute and processing of the data. Our offering, BeyondLearning, is designed to lower that barrier of entry, and it's specifically designed for small to medium-sized businesses. So what we do is we work at scale because we have multiple clients on our platform, and what we can do is we can onboard your data, and we build the models on our platform, and we provide these web service endpoints where you can get data from our platform that allows you to make business insights. So our whole goal with BeyondLearning is to actually make it available to small to medium-sized businesses, so you can get all the benefits of machine learning without building this large infrastructure that these enterprise companies have a leg up on you with.
It's also worth noting that a lot of small startups that elect to invest heavily in data science early have been tremendously disruptive recently. Airbnb is a great example, right? They're a born-in-the-cloud startup, and they invested in data science as a practice and machine learning as a core part of what their business value proposition was going to be from the very get-go, and had tremendous success. That is expensive and risky because you have to invest a lot in that infrastructure out of the gates, but that it is something that small to medium businesses have had success in doing, going heavy into machine learning internally from the gate.
You do have to have data to support the machine learning practice, though.
And a really crisp idea of what is not already out there in the world that none of the big guys are competing with you on, that you're going to be able to tremendously improve with machine learning. So companies like Airbnb and Uber, for example, right, were tremendously disruptive because they had an idea that was sufficiently novel where machine learning could, interrupt normal business processes. So there's a couple of different ways that you can try to attack that. If you're a startup that is not necessarily on the beaten path. If you're in a major industry and you're a small to medium-sized business with fairly well understood business problems, then it's more likely that you want to use something that like a software as a service such as BeyondLearning to reduce that barrier to entry, rather than invest in a data science team yourself. But it depends on your business.
Okay. Great, thanks, Ben.
All right. Thank you all for attending this webinar. We really appreciate your time here. Just want to say that this webinar is recorded and will be available on BrightTalk should you want to take a look at it later. We also created a sales pipeline application for you to really quickly test out how ML can be utilized to predict your sales opportunity results. So that information to that will be available in an upcoming email sent out to you. Once again, thank you. Really appreciate your time, and we look forward to working with you to leverage machine learning for your business. Cheers.